Hello my dear students, welcome back to my channel. Today I am going to start assertions and reasons type questions of chapter 1 electric charges and field. In the previous video I already discussed about many case study based questions and this is second type of MCQ assertions and reasons. So how you solve these type of questions, right? So let us try to understand this one. So in these type of questions, four options are given and these options are same for all questions. It means in any question, option remains same, A, B, C and D. So how you solve these type of questions? Okay. In each question, two statements are given. One statement is called assertion and another statement is called reason. Now, how you get the answer after reading these two statements, assertion and reason? First, you read assertion and find whether it is true or false, right? Then after that, you read this statement reason and find whether it is true or false, right? Now, here C and D option are very easy. If you find that assertion is true and reason is false, you can easily get answer number C. If assertion is true and reason is false. And if assertion is false and reason is also false, then you take easily answer number D if both assertion and reason are false. So C and D option are very easy. If assertion is true, reason is false, you take C option, and if both assertion and reason are false, you take D option. Now, difficulty comes when both assertion is true and reason is true. If both are true, then it becomes little bit difficult to solve question, and that's why assertions, reasons are complicated due to these options A and B. Now, how you get the answer if both assertion and reason are true? If both are true and if reason is correct explanation of this assertion, then you take option number A. Both assertion and reason are true and reason is correct explanation of assertion. Now, how you get the correct explanation? You just read assertion. After that, you just put because or since anything and read this as reason. If you get the correct answer, it means reason is correct, right? Reason is correct explanation of assertion, you take A. Otherwise, if reason is not correct explanation of assertion, you take reason, this is statement B option, right? So, in each type of questions, assertions, reason, four options are given A, B, C and D. If assertion true, reason false, C is both false, B. And if both are true, then A and B. It may be A or it may be B. But if reason is correct explanation of assertion, you get A answer. And if reason is not correct explanation of assertion, you get B answer. In this way, you solve assertions and reason type questions. Now, let us try to solve question number 1 based on this assertion and reason, right? Okay. Question number 1 is, now, question is, first you read this statement assertion. Here, assertion is given that if the bob of a simple pendulum is kept in a horizontal electric field, its period of oscillation will remain same. It is true or false? Guess it? Yes, guess the answer. It's true or false? Its period of oscillation does not change. It will remain same if the bob of a simple pendulum is kept in a horizontal electric field. It means this statement is true, right? Now you read this second statement, reason. If bob is charged and then kept in a horizontal electric field. Now this time bob is charged, it has some charge, and then kept in a horizontal electric field. Then the time period will be decreased. This reason is true or false? This statement is true or false? First find it, this one. Yes. Pause the video and try to solve it. If the bob is charged and kept in horizontal electric field, then its time period will be increased, not decreased. It means this statement is false, right? Now, you can easily get the answer. If assertion is true and reason is false, then which option is correct? Yes, assertion is true and reason is false. Option number C is correct, this one. If assertion is true but reason is false, right? So, you get C option, right? So, for this question, answer is C. In this way, you solve assertions and reason type questions. First, you read the two statements assertion and reason and find it whether it is true or false. Then you can easily get the correct option, right? Next, question number 2. Now, second one is assertion. Read this statement very carefully. Acceleration of charged particle in non-uniform electric field does not depend on velocity of charged particle, right? What is the formula for acceleration? F equal to ma, right now? So acceleration is F by m, and F in terms of electric field is what? Q into E by m, right? So if the charged particle is placed in a non-uniform electric field, it means varying electric field, its acceleration is changing right now. But this acceleration depends on velocity of charged particle, does not depends on velocity of charged particle. Here it is written does not. Acceleration depends on charged particle or does not depends on charged particle. Yes, guess the correct answer. Yes, this statement is true. Acceleration does not depend on velocity of charged particle. It changes with change in electric field, right? So this statement is true. Now read this second statement, reason. Charge is an invariant quantity. That is, the amount of charge on particle does not depend on frame of reference. Yes, it is true or false? Amount of charge does not depend on in which frame it is kept. It is invariant, does not changes with change in frame of reference, right? So this statement is also true, right? Now here both statement is true. Now there are two options, A or B. A is if reason is correct expression of assertion, and B is reason is not correct expression of assertion. Is there any relation between assertion and reason? How you find this one? You just add because and then try to get the correct answer, right? Acceleration of charged particle in non-uniform electric field does not depend on velocity of charged particle because charge is an invariant quantity. That is, amount of charge on particle does not depend on frame of reference. Yes, this reason is absolutely correct expression of this assertion. It means which option is correct? Option number A. Both assertion and reason are true, and reason is correct explanation of assertion. In this way, you solve this type of questions. Now next, question number 3. Here assertion is net electric field inside a conductor is 0. It is true or false? Inside a conductor, net electric field is 0. Yes, this statement is correct. Reason. Total positive charge equals to total negative charge in a charged conductor. Yes, find it. This statement is correct or false? True or false? Total positive charge equals to total negative charge in a charged conductor. What? Charged conductor. Charged conductor means some charge accumulates on the surface of the conductor. So in that case, if conductor is charged, total positive charge equals total negative charge? No, this statement is false. So here assertion is true but reason is false. Which option is correct? Option number C. Assertion true and reason false. Right now? Okay. Now after this, next question number 4. Question number 4 is assertion. All the charge in a conductor gets distributed on whole of its outer surface. This statement is true or false? Yes. All the charge in a conductor gets distributed on whole of its outer surface because inside the conductor net charge is 0. So if the conductor is charged, then where that charge accumulates? It accumulates on the surface of the conductor. So this statement is true, right? Reason. In a dynamic system, charges try to keep their potential energy minimum. Yes, this statement is also true. That's why all the charges in a conductor gets distributed on whole of its outer surface because in a dynamic system, charges try to keep their potential energy minimum. Both assertion and reason is true, and this reason is correct expression of assertion. So option number A is correct, right? Hope it's clear to all of you. How you find the correct answer? First you find whether assertion is true or false, reason is true or false. If both are true, then find by adding because, since, whether this reason is correct expression of assertion or not, right? In this way you get the correct answer, right? Now question number 5. This says assertion is the Coulomb force is dominating force in universe. This assertion is true or false? Coulomb force is dominating force or gravitational force? This statement is false. Okay. Read second statement. Reason. The Coulomb force is weaker than gravitational force. This statement is true or false? This statement is also false. The Coulomb force or electrostatic force is stronger than gravitational force. How much times is stronger? 10 to the power 39 times is stronger than gravitational force. So this statement is also false. And if both assertion, reason are false, option number D is correct. If both are false. Hope it's clear to all of you. If both assertion and reason are false, then option number D is correct, right? Now next question number 6. In this one, the tires of aircrafts are made slightly conducting. This statement is true or false? You know, aircraft, the tires of aircrafts are made slightly conducting so that extra charge goes inside the earth due to frictional process between the tire and the ground. Charges develop on the surface of the right now. So to all these charges goes inside the earth by the earthing process, the tires of aircrafts are made slightly conducting. This statement is true. Now read this statement. Reason. If a conductor is connected to the ground, why it is connected or conducting? The extra charge induced on the conductor will flow to the ground. Yes, this statement is absolutely correct and it is correct expression of this assertion. Why the tires of aircraft are made slightly conducting? Because if a conductor is connected, it means that tire made up of conductor is connected to the ground, the extra charge induced on the conductor or tire will flow to the ground, and it is only done for only safety purpose, right? So both are true and reason is correct explanation of this assertion. So option number A is correct, right? Hope it's clear to all of you right now. Now next question number 7. What is given in question number 7? It is given that assertion. In a non-uniform electric field, the dipole will have translatory as well as rotatory motion. You know, in a uniform electric field, you already discussed about, about these things. When dipole is placed in a uniform electric field, it experiences some torque, but net force acting on the dipole is 0. Net force 0 means no translatory motion, but here not uniform. Non-uniform electric field is there. It means electric field is varying, variable electric field. So in a non-uniform electric field, a dipole will have translatory as well as rotatory motion. Translatory means net force is 0 or not? Not 0. And rotatory motion means it experiences some torque also. It means it has both translatory as well as rotatory motion in a non-uniform electric field. This statement is true, right? Now reason. Read this statement. In a non-uniform electric field, a dipole experiences a force as well as torque. Yes, this statement is true. It experiences some force, that's why it has translatory motion, and it experiences some torque, that's why it has some rotatory motion. So both statements are correct and this reason is correct explanation of assertion. So option number A is correct. Hope this question is also clear to all of you, right? Now next, after this, question number 8. What is given in this question? Assertion. The charge on any body can be increased or decreased in terms of V. Yes, quantization of charge. Total charge on any body is an integral multiple of that fundamental charge. Fundamental charge means smallest value of charge is what? Charge of an electron E. So Q equal to ME, you know quantization of charge. According to this one, you find whether this statement is correct or false. Assertion: the charge on any body can be increased or decreased in terms of E. Yes, this statement is correct, right? This statement is true. Charge, total charge is equal to NE. So it can be increased or decreased in terms of E only. It is an integral multiple of E, right? Reason: quantization of charge means the charge on body is integral multiple of E. Yes, this statement is also correct, and this reason is true explanation of this assertion. So which option is correct? Option number A, right? In next question number 9. In this question, it is given that first statement assertion: on going away from a point charge or a small electric dipole, electric field decreases at the same rate in both cases. Again, read this statement: on going away from a point charge or small electric dipole, there is a small one point charge Q and there is a small electric dipole plus Q and minus Q. On going away from both this point charge and a small electric dipole, the electric field decreases at the same rate in both cases? No. In case of point charge, electric field is inversely proportional to R square. And in case of electric dipole, electric field is inversely proportional to 1 by R cube. Right now? So, this assertion is true or false? Electric field decreases at the same rate? No, rate is different. Here square of R, here cube of R decrease. So, this statement is false. Reason: electric field is inversely proportional to square of distance from the charge or an electric dipole. In both cases, electric field is inversely proportional to square of distance. Inversely proportional is correct, but not square of distance from the charge or electric dipole. In case of point charge, it is square of distance, but in case of electric dipole, it is cube of that distance. Right now? So, this option is also false. Right? And if both assertion and reason are false, which statement is correct? Option number D. Right? So, answer for question number 9 is option number D. Right? Next, question number 10. Here, assertion is given that insulators do not allow flow of current through themselves. Yes, this statement true or false? You know, insulator, conductor, insulators do not allow flow of current through themselves. Yes, only conductors allow current to flow through themselves. This statement is true, right? Reason: they have no free charge carriers. Yes, insulators have no free charge carriers. Both statement is true. And why this insulator do not allow flow of current through themselves? Because they have no free charge. This reason is also correct explanation of this assertion. So, option number A is correct for this question number 10. Hope it's clear to all of you right now. Next, question number 11. Here, in this question, it is given that first statement assertion: if there exists Coulomb's attraction between two bodies, both of them may not be changed or charged. They may be charged or not charged. This statement true or false? This statement is true. They will be of oppositely charged. This statement is, if there is a force of attraction between two bodies, they must be oppositely charged, right? And this statement is also true. But this reason is correct expression of this assertion. Put because, right? Again, read this statement: if there exists Coulomb's attraction between two bodies, both of them may not be charged because they will be oppositely charged. No, reason is not correct expression of assertion. Option number B is correct for this question, right? Okay. Next, question number 12. In this question, wait. Question number 12 is, yes, assertion: the mass of a negatively charged body decreases. This statement is true or false? There is a positively charged body, there is a negatively charged body. So the mass of a negatively charged body decreases. You know mass of electron, how much? You know mass of proton. So mass of negatively charged body decreases or increases? This statement is false. The mass of negatively charged body increases na, because this negative charge has also some mass. Mass of electron is what? Mass of electron is 9.1 into 10 to the power minus 31. Right now, whatever mass, but the mass of a negatively charged body not decreases, it increases. This statement is false. Reason: by losing electrons, a body gains positive charge. Yes, by losing electrons, the body becomes positively charged. Right? But this statement is true or false? By losing electrons, a body gains positive charge. Again, read this statement. By losing electrons, there is one A and one body B. Charge is transferred from A to B. Electrons are transferred, right? So this A becomes positively charged and this B becomes negatively charged. Those bodies which gains electrons becomes negatively charged. Those body which loses electrons becomes positively charged. What is written here? By losing electrons, this A body loses electrons. It gains positive charge. No, it not gains positive charge. It becomes positively charged. So this statement is also false. So which option is correct? Option number D is correct explanation of this question, right? Both assertion and reason are false, right? Next, question number 13. The torque on a dipole in a uniform field is due to net internal force acting on it. You know, when torque is placed in a uniform electric field, it experiences some torque. This torque is due to net internal force acting on it. Yes, this statement is true. Reason: torque applied on a dipole neutralizes the force and rotates dipole. Yes, total force is 0, but torque is not 0, and due to this it rotates the dipole. So torque applied on a dipole neutralizes the force and rotate dipole. This statement is also correct, and this reason is correct explanation of assertion or not. That again you read this statement by adding because the torque acting on a dipole in uniform field is due to net internal force acting on it because torque applied on a dipole neutralizes the force and rotate dipole. Option number A is correct, right? Both assertion and reason is correct, and reason is correct explanation of assertion, right? Next, question number 14. Total flux through a closed surface is 0 if no charge is enclosed by that surface. Suppose there is an enclosed surface and net charge inside this unit is 0. So what is written? Total flux through a closed surface. What is flux? Phi equal to, according to Gauss theorem, E dot ds equal to Q by epsilon naught, right now? So it is written total flux through a closed surface is 0, phi is 0 if no charge is enclosed by the surface. Yes, if charge is 0, then phi is also 0. It means this statement is correct, right now? Hope it's clear why this assertion is true. Total flux through a closed surface is 0 if charge is enclosed by that surface is also 0, because phi equal to Q by epsilon naught according to Gauss theorem, right? Read this statement. Reason: Gauss law is true for any closed surface no matter what is the shape or size. Yes, this surface must be closed. Gaussian surface must be closed, whatever its shape or size, whatever its dimension, right? It does not depend upon shape and size. Only the surface must be closed, and what is the amount of charge enclosed by that surface. Total flux depends on that surface, right? So Gauss law is true for any closed surface no matter what is the shape or size. This statement is also true, and whether reason is correct or not. Total flux through a closed surface is 0 if no charge is enclosed by the surface, because Gauss law is true for any closed no matter what is the shape or size. Only depends upon total charge enclosed by the surface. So this reason is also correct explanation of this assertion. So option number A is correct for this question number. So hope it's clear to all of you how you solve assertion reason type question, right? So with this, I am going to end the class. If you want these type of videos, please write in the comment box so that I will make more videos for you. Up to then students, please keep revising and stay tuned with this channel. Thank you.